Alright, kiddos, so you're getting your notes out for section 10.8. I'm getting your homework page up for aforementioned reasons that I will fill people in on that are gone today. Nolani and Sean, hope you had fun at Disneyland. Even though you're not there yet, but you'll hear this in the future. That's kind of cool. What? Yeah. Don't worry, you're good. This is taking forever. Alright, kiddos, here we go. Thank you. I like it, and I can say that means I can't get your attention. My voice is dying, so shush. Okay. Kiddos, what were we working on yesterday at the very end?
This.
Graphing this problem and asking ourselves a few questions. What kind of symmetry? How did I already answer that with polar axis?
Polar axis because it's cosine.
Because it's cosine. Any function that strictly has cosine does not have theta by itself outside of the cosine, or any other trig function is going to have polar axis symmetry. Okay? And then we're trying to ask ourselves questions like the maximum, which can be the farthest positive or negative, because it still determines the tick marks, and we think of maximum as an absolute value of R. We're looking for the maximum and any zeros, just to describe them, as well as trying to figure out the picture of the graph without necessarily having to memorize all sorts of formulas as far as what are limasols and what are roses and what are lemniscates and what are circles, and there are even lines and conic sections. Anyway. So, what do we need to do in order to find each of these points, cool kids? Solve. But in order to solve, what do we need? To know the unit circle, right? You guys didn't believe me when I said you needed it. Okay, so when you plug and chug, question, what is cosine of 0?
1.
Good. So we end up for the first one, oh, it's a little too high. Yeah, with -1. For the second one, what is cosine of pi over 3? Why do we choose pi over 3 and not pi over 6 or pi over 4? Yeah, it's a pretty fraction instead of a yucky radical that we don't know. So we have, what's 2 times 1/2? What's 1 minus 1? Hey, we found a 0 already. Okay, what's cosine of pi over 2?
0.
Yeah, cosine is 0. So 1 minus 2 times 0 is going to be 1. Right. As we keep on going to pi over 3, cosine is -1/2. Second quadrant, cosine's negative. How does that change things? 2 times 1/2 is still 1, but a negative times a negative is a positive. What's 1 plus 1? Well, that's bigger. And then for pi, what's cosine of pi?
We see the pattern though. You can just plug it away. -1, 2, 1, 2.
Yeah, if you use the right, but you need to know the angles in order to graph the points, you know what I mean?
Yeah.
But yeah, otherwise you could. So we can plug in, and that ends up being 3. Question, did we somehow in here, did we find where cosine was 1 and where cosine was -1? And didn't we talk about the maximums are usually going to happen at one of those two places? So what can we say as far as, if we're listing our characteristics of our graph, we can say for symmetry, it has polar axis, right? For maximum, what are we going to say? Yep, 3. Good. Question, is there going to be a 0 at every pi over 3? No, because 2 pi over 3 doesn't have a 0. So question, can you guys help me out? What would be another 0? Because there's going to be more than one. But it's not 2 pi over 3, so what else are we going to have? 4 pi over 3, no. Because 4 pi over 3 is going to be a negative just like 2 pi over 3. So it's going to be instead? That's 2. Oh yeah, 7. I was thinking 5 first. 1 pi over 3, 5 pi over 3. Then it would be 7 pi over 3, and then we'd have to skip again. 11 pi over 3? Is that right?
Yeah.
So we'd have at the pi over 3 locations and the 5 pi over 3 locations. So those two angles and their coterminals. We could write them as equations, but yada yada. Okay, so now that we have each of these, we're just going to review one last time. How do we graph everything? Since it's a cosine and we only did pi over 3s, let's just mark those angles. Tick marks, how many am I going to do? Good. You guys see how we don't need those snazzy polar graphs? It might be nice, and you might print them out for homework. I don't mind. But do you have to have them? No.
So the test is going to be no calculator?
There's going to be a no calculator portion just to test your unit circle / polar axis. Or sorry, polar graphing abilities. So it'll probably be like graph a parametric equation, like with a table. And then probably a graph 1 or 2 polar. Maybe graph some polar points and then like a polar graph. And then the rest will be calculator for like eliminating the parameter, maybe converting. Do you actually need your calculator for anything? I'll see. Wait, we're graphing our points. So 0, -1, isn't that back here somewhere? Pi over 3, 0. Pi over 2 is 1. Oh, this is looking weird, right? 2 pi over 3 is 2. Remember, we connect the 2 tick marks. That was way thicker than I meant it to be. And then pi is 3. Does anybody have any idea how to connect these? We know the order. Hopefully you're paying attention. It goes this point, then this point, then this point, then that point, then that point. Yeah, it does have an arc to it if we're going backwards. The question, what's with that other random point? If you were to keep rotating, like think about rotating the paper. Have you guys ever done those ones where you like put your pencil down? It has like a stencil and you like rotate the paper and it makes circles.
Oh yeah.
Maybe. If I keep rotating the paper, there needs to be a rotation in almost any polar graph. Would you do this weird like up thing? Or would you go down? It's going to be a limaçon. Because you're going to have that little psh. And then when you copy it, because remember, cosine has polar axis symmetry, so what's below is going to go above in the next round if you were to keep on doing angles. What's above is going to go below if you were to do the next round. You'd end up with a limaçon. Approximately symmetric, which that one is not, but that's okay. We pretend. Now, why wasn't it super obvious that this was supposed to connect like that? You guys mostly figured out this one, right? Maybe you figured out keep rotating to that one, but a lot of you didn't realize you were supposed to keep rotating to there. What would have filled in the gaps if we had taken the time or been courageous enough to do it? Yeah, so done like pi over 4 and pi over 6. So if you're not sure, couldn't you like get the decimal and then kind of graph it? And guess what? It would be like a negative little decimal do for each of those. So you would have had that point and that point. Then you would have known how to connect. Does that make sense? So it's not that you can't get it. I was just trying to show you if you can learn how these limasols or how these polar graphs connect, the idea of them, you can not have to worry about those yucky square rooty things and just use the nice angles, but that doesn't mean that as you're learning, you should totally ignore them. Maybe it would be helpful to fill in some of the holes by actually using the angles in the unit circle. So then, kiddos, as we talked about before, there are equations where in the last page, if you weren't sure exactly what was going on, and if you took the graph 1 minus 2 cosine theta, how does this chart work? How could we match it to what it's supposed to be? We know it fits this, right? And then what? Do you see what we're looking at for each of them? A over B. So who's A? 1. And who's B? So looking at A over B, if you were to learn these formulas, if you want a way of like for sure knowing exactly what's going to happen, you would just go ahead and match this 1/2 and say, hey, that's less than 1. So I have a limasol with an inner loop. And as you guys go to look at your graph, if you had figured out this part, seeing him, then you should have known, oh, there's a little inner loop and it's going to continue. Does that kind of make sense? So the tables are useful. It just depends on whether or not you want to memorize them or whether or not you just want to know your unit circle. Luke. Not specifically. Let's do it this way. Ready? I want you to know that each of these 3 are limasols. I'm not going to make you know the dimple, the convex versus the inner loop. We'll just call them limasols. This one, though, is special. It's the one that goes all the way into the cusp, all the way into the 0 and then comes out. It's like a weird little distorted heart. I do want you to know. How about that? So these 3 are limasols. This one is a cardioid. As we come over here, this one's easy because they're just all roses, and you could say a 3. Oops, I'll move the picture. A 3-petaled one, 1, 2, 3, 4, 5, 6, 7, 8-petaled rose, a 5-petaled rose, a 4-petaled rose. Like it's just a rose. So a rose for all the flowers. I know they look like daisies, etc., but it is what it is. And then circles, you guys should be good on. You might call it an ellipse. If you do zoom square, remember that orients your picture, and you'll see it's a circle better. I probably won't even ask you a circle because that's just like a conic section. But the lemniscate would be the other special one. So I'll go ahead and erase those ones. I'm erasing, because you don't have to memorize the formulas. It's only if you want like a fail-safe to know which one's which. We'll just say the lemniscates are the infinity signs. Is that good? So then with that, kiddos, section 10.8. For those kiddos that are gone, we talked about at the beginning of class how today we could go over the evens, but the kiddos were honest, and long story short, they're not exactly prepared to go over the evens. So I'm going to go ahead and scroll down so that they can see the 10.7, the 10.8, and the test review. Some people have 10.7 totally attempted. Some people have 10.7 and 10.8 totally attempted, or at least mostly attempted. So they're going to be starting on the test review. I'm calling it, online it's called a test. Literally, it's just a quiz. I'll call it a quest just so it doesn't sound like it's pointless, because it's not. Probably be worth like 20 points, maybe 25. We're going to go ahead and check the evens at 10.7, 10.8, and the review on Monday. We're going to go ahead and have a work day. I'm going to pass out your guys' tests, so the only people that aren't going to get it are the people that are not here. Well, I don't even have them in order as far as days. That's the same time. I found another one. And another one. And another one. Okay, those real quick. I ran out of copies of my correction papers. I just put in a request for more. I just kind of don't notice when like the kids are passing them out and I'm not. So I have a few. Is there anybody who like for sure that you're going to work on corrections this weekend? You're going to not do until after the test? I'll just keep these 4 copies that I have, and you guys can get copies on Monday. Sound good? Alright, you just want to see. Keep them safe, because if you lose them, can you do corrections? And this time it might be even more beneficial, because I might give them maybe like a 5th points back. Oh, or if you guys will do the end of 2nd semester, I'll do a 5th, because some of you love it. So 5th points back to the ones who are able to get right. In no particular order. It's not on my web because I've just been barely making it through each day this week. But I'll get it this week. Luca. My A's. Luke, Ella, and Sean. I think they studied their formulas and how to use them. The rest of you guys didn't absolutely know what's. If you guys want to know how much higher you can get, remember, subtract your score from 100, divide by 5, add it to your score, and say, that's how I could do it if I do good corrections. Nicole, come on down. Jesse, Lamani, she's what's that? Here. Amanda. Harris. Eric. Listen. Alyssa. Anna. Green.
Wow.
Alex. Subtract 100, divide by 5. That's how many points you get.
What the?
Alex. Brandon. Celeste.
That is solid.
Does that make sense? Subtract 100, divide by 5. That's how many points you get.
More than a seed. Did you call me the degenerate?
Oh, I was just looking at the technical category, but I can just add it straight in if you have students.
Did you call me a degenerate in this?
Wait, what number is that?
That's
Do you guys
number
notice that your
90.
scores don't even reflect that I made number 14 a complete bonus?
Oh, God.
Yes. And 9B,
Let's go. I got the bonus.
and 9B. 9B, if you look at that just really quickly, it should look like an ellipse, because there's a plus x squared, y squared. So I took ellipse for full credit. But if you started completing the square, the right-hand side does not become possible. It's a degenerate. So technically, it should have been none of these, but most of you guys didn't complete the square. So I took E. It was the, well, no, I took B. E was the proper answer if you actually completed the square. It became a degenerate, not you. You're not a degenerate. I'm not it. All right, cool kids. Take advantage of my grace and my desire to help. Let's get some work done right now, okay? If I see you not getting work done, I may not be so gracious on Monday.
Yes.
So, let's get some good work done. That way, I feel like we were still productive. Yeah, if you want a book, come grab it. If you want to run to your locker because it's in the hallway, go get one. Yeah, don't mind. If you want to put on music, I don't mind too.